The third method that we're going to look at is if your rational expression has imaginary roots. So that would look like y of s is equal to s plus 3 divided by s plus 5 times s squared plus 4s plus 5. So in this case, this expression here can't be broken down. You can't factor this into real roots. Technically, you could factor it into imaginary roots, but we're not going to do that. That won't be helpful for us in this case. So here, what we do instead is we leave that part as a polynomial. So in this case, you end up with c1 over s plus 5. So y of s is equal to c1 over s plus 5 plus c2s plus c3 divided by s squared plus 4s plus 5. So in this case, and this is really important, we left the numerator here as a second order equation, which means we made our numerator a first order equation with a variable s in the top here. So instead of just calling this c2, we called this c2s because our denominator here is second order. Now we solve our c1 exactly the same as before. So our c1 will be equal to s plus 3 divided by s squared plus 4s plus 5, evaluated at s equals minus 5. This gives us minus 5 plus 3 divided by minus 5 squared plus 4 times minus 5 plus 5. These are 5s, not s's. And this will give you minus 1 over 5. So we solved for our coefficient 1. For coefficient c2 and c3, we use cross multiplication. Now this method actually works for the other methods 1 and 2 as well. You could also use this. But how it works, I'm going to scroll the screen up. So for cross multiplication, we have now our value for c1. So now what we have is we have our original function s plus 3 divided by s plus 5 times s squared plus 4s plus 5. That was our original expression. And we know that this was equal to c1 over s plus 5. So I'm going to replace the value for c1, which was negative 1 over 5, divided by s plus 5, plus c2s plus c3 divided by s squared plus 4s plus 5. We know that this has to be equal to this by definition. So what we do is we multiply both the entire equation, we multiply it by the denominator. So s plus 5 times s squared plus 4s plus 5. And what we're left with is, on this side, we just have s plus 3, because the denominator here, this entire denominator cancels with that. And then on the right-hand side, we end up with negative 1 over 5 times s squared plus 4s plus 5, plus c2s plus c3 multiplied by s plus 5. In this case, we only have one equation, and we have two unknowns, c2 and c3. But by grouping like terms, you'll find that we have enough information to solve for this. So if we expand all of these equations, what we end up with is s plus 3 is equal to negative 1 over 5s squared minus 4 over 5s minus 1, because this would be negative 1 over 5 times 5. Then you end up with plus c2s squared plus 5c2s plus c3s plus 5c3. Now I'm going to simplify this a little bit. So we have s plus 3 is equal to, and here I have two terms with s squared, so s squared times negative 1 over 5 plus c2. Then I have plus s times negative 4 over 5 plus 5c2 plus c3. So now I've gotten rid of this term, this term, this term, this term, and this term. And what I'm left with is plus 5c3 minus 1. Now I know that, on this side of the equation, I don't have an s squared. And on this side of the equation, I'm saying that negative 1 over 5 plus c2 times s, sorry, I have the term negative 1 over 5 plus c2 times s squared. So from this, I know that negative 1 over 5 plus c2 has to be equal to 0, because there is no s squared on the left-hand side of the equation. So from this, I know that c2 has to be equal to 1 over 5. To solve for c3, I can see over here on the right-hand side of the equation, I have 5c3 minus 1. These are all coefficients. And on the right-hand side of the equation, my coefficient is equal, sorry, on the left-hand side, I have a coefficient equal to 3. So now I know that 5c3 minus 1 has to be equal to 3. So in this case, c3 is equal to 3 plus 1 divided by 5, which is equal to 4 over 5. We could confirm this. We can double check our work, because we also know that this grouping here has to be equal to 1 over here. So let's check our work. I'm going to move the screen up a bit. So now we know that negative 4 over 5 plus 5 times c2, which is 1 over 5, plus c3, which is 4 over 5, has to be equal to 1. Minus 4 over 5, 5 over 5 cancel, the 5's cancel, and we're left with 1. That means we know we did good here. The final answer, y of s, will be equal to negative 1 over 5 divided by s plus 5 plus 1 over 5s plus 4 over 5 divided by s squared plus 4s plus 5. And you'll notice that this equation, you can take the integral of this one, because here we have an s squared and here we have the derivative s, so we can use our integration methods that we know to deal with this problem now. Again, partial fraction expansion is a very important skill. You're going to be using it continuously in a lot of different courses.